guys? Hope you're doing well. Today we are going to solve this question, maximum matrix sum. Now here's some of the description of the question and all of this. But before getting to the solution, I want to give you the clear context of the question. So let's go to the test case one. So let's just consider that we have a matrix like this. Now in the question title, as you can see, the maximum sum of the matrix. So what does it mean? Basically, you just need to sum up all the values of the matrix and give the value. Let's say right over there, here's one, then minus one, and if I try to over sum, it comes out to be zero. Now, according to the question, we have given one kind of operation which we can only perform to maximize the sum of the matrix. So, which is basically we can take a pair of this. Where let's say I'm at this place. Let me just change the color. Let's say I'm at this place. I can just take adjacent pair this, or I can take adjacent pair this. I mean, we can take both of it. So let's say I just take the first one, and I can do a multiplication operation of minus one. So minus one, basically the intuition behind the question, what they want us to change the symbol. So since we know that if I multiply to minus one, it's gonna change the symbol of the value. So it becomes this. Although if I try to see the overall negative number still not change, it is still two negative numbers. But there is another thing. I mean, I can also do another operation to the same value which I'm right at and can do the same operation. So in this way, it become positive number and this become positive number. Now, as you can see, if I try to do the maximum sum of, if I try to do the sum of the matrix, it comes out to be 4. And that's what the question output exactly means. I mean, that's what the question want. Now, I mean, if you were thinking or observing for a while, you must be thinking that, I mean, what if I'm being clever and what if I try to just give the absolute value of all each of the element of the matrix and just going to give the sum of it. I mean that will work. I mean it's going to be obviously the absolute positive value of the matrix of the sum of the matrix of each of the elements. But the catch is that's why they have given us the quotient. I mean example 2, test case 2. So that basically let's just consider that what if in our matrix instead of even positive numbers, I mean I just gave you the hint. Now what if I have three negative numbers? So I'm just right at this place. Let's say I'm right at this place. If I've been clever, I can just simply turn this thing into two positive numbers since I have the operation which I can perform according to the quotient, but there is one negative number left. Even though if I try to pick any of the adjacent values of it and try to do the same operation, I'm always going to be left with one negative number. Although if I do this will become negative, this will become negative if I do the same kind of operation, and this could also become negative. So here's a catch. So that's why we can't actually use this kind of approach in which we're going to take absolute value, which means the positive value of all the elements, and then sum up and give the maximum result. So that's not how it's going to work. So you must be thinking, I mean, okay, I mean, if that's the case, question wants, I mean, we can just simply use a brute force approach of backtracking and just simply do a backtracking. I'm just gonna call it a short form backtracking. I mean, yeah, we kind of use that thing, but the complexity is literally going to be exponential. I mean, it's kind of like this 2 raised to n. I mean, it's kind of big. So, I mean, that's not the good approach. So basically, I mean, I'm gonna tell you the solution, the best solution which we have found on Leetcode today. So basically, I mean, it was kind of really hard to get it, but if you have studied maths in a good way, I mean, you will get to know the pattern behind it. So, I mean, let's just consider a matrix for you guys. I'm gonna draw. Let's say I have this matrix minus one. I mean, just change me. Let me change the color. So yeah, minus one right over here, then one, and 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 minus one over here, and one and one. So what if I tell you that this minus 1 can travel at any place of this matrix? Let me show you why. Let's say I'm at this place. What if I drew a same operation right over here? This become positive and this become negative. So as you can see, the negative value just travel over here. I can do the same thing right at this place. I can just do the same operation, it become positive and this become negative. So again, the matrix have traveled. Then after this place, as you can observe that we have two negative value. If I do the same operation, it become positive. And as a result, what I can see that in this matrix, if there were two even numbers, then if as even number can travel, it is possible that all other number can be positive. So here's the first hint which I just shown you. Now let me just show you the second hint. So the second hint is basically, let's say I have the same matrix and I do the same kind of operation. Let's say negative number is over here and negative number is over here. Even if I try to do a backtracking approach, all the possibility of this matrix is going to be this same kind of number, but in shuffled order, in which this negative number will travel at any place of the matrix. It could be anywhere. But if we try to look closely, it simply means that we always going to left with one negative value, which means that if I have odd numbers of negative numbers, even though in the end after doing all the operation there always going to be a one negative number left. So here's the best explanation of the hint which I can give. Then after that, what does it mean? That it simply, let's just get back to the test case 2. So hopefully after getting the idea, intuition behind it, I hopefully think that we can tackle this question. So as you can observe that if we got odd number of positive value, we can just simply know that there is always, I mean, if I do all the operation, there is a possibility that there is one number which is left negatives. So which number should we pick? Should we pick this negative 2 since it is the smallest value, or should we pick this? Okay, let's just try to pick this. But what if I try to pick this and these value are comes out to be positive? As you can observe that even if we try to do the summation of all these value, I mean it's going to be some value, but it's not gonna be the maximum value, because if I'm being honest, if I observe clearly, if this was the negative number and if I kept this thing as negative and keep this thing as positive, it comes out that this was the more negative number. So it's going to reduce the value. Let's say of x, it's going to subtract it by 3. And there is one other case in which there is value of x and it is minus by 2. So which of these, what do you think, guys, is the maximum? Obviously this number. So I mean, why this number? So basically the thing is, we're going to pick that negative value whose absolute value is 1. I mean, let's say, I mean, the negative value, the smallest value out of this matrix was minus 3. That was a greedy approach. But when we saw the mathematical formula, we found out that if I try to pick the absolute, I mean absolute minimum value and do the negative of it, then comes out to be the greater value. That's the main intuition behind it. So that's why we're gonna pick this. So let me just code it up for you guys. I mean that was all of it. So what do we observe? That if there is even number, we know that the matrix value all can be positive. But if we encounter any odd number of negative value, it simply means that we're gonna pick that I mean minimum absolute value and make it a negative. So that's the intuition behind it. Just code this thing up. So how are we gonna start? So basically, I don't know how what variables are, so I'm gonna iterate over the array first. So I'm right now in the row of the matrix. Then after that, I'm at each element of the matrix. So I need to calculate the sum of it. So sum of it obviously going to be the absolute value of element. Wait a minute. I mean, the sum is not defined. So basically what I'm gonna do, I'm gonna create a variable started with 0. So you must be thinking, why are we picking the absolute value? So for right now, we are just considering, assuming that the matrix have negative elements and these negative elements are in even number. So after that, what we're gonna do, we're gonna create a minimum value and we're gonna store the minimum value of itself and going to store the absolute minimum as element value. So which I've just shown you right over there, in which if I try to pick this one and this one and the maths behind it. So yeah, so pretty much that's it. So again, minimum is not defined. So again, I'm gonna create a variable, I'm gonna call it a minimum, and the float is going to be infinity. I mean, why are we picking infinity? So that we can get the minimum value anyways. Since if I try to make any number, what if the matrix numbers comes out to be greater than the minimum value? That's why we have taken up the infinity as a value. Now what next? Well, simply we're gonna calculate the number of negative numbers so that we can handle the odd case. Since this can be, I mean, this case can simply cover up the negative. I mean, what do we say, the even case? So here's the negative element variable. So we're gonna call it as negative count and negative count. I mean, what if the element comes out to be negative? If comes out to be negative, we can simply that number of negative increase. So this is the how many negative numbers are there. And if that was, I mean, if the matrix contains only the even number of negative counts, then we simply going to return the sum as a result. But no, since there are some cases in which the negative count is odd, so it is odd, we can just use this kind of operation. So you must be thinking, why and this? So let me tell you one thing. What if, I mean, if you consider odd number and if I do a binary denotation of it, it's going to be like this 1 1. And if I try to do binary, what do we say? What just call it whatever you want to say. I mean, what if I do binary of this? So it's comes out to be 1 and 0. So in odd numbers, there is always possibility. I mean, it is. I mean, it's always that end value, the least significant bit is always 1. But in odd number, it is 0. So if I try to AND operation with this, if I do AND operation of this comes out to be that it comes out to be 0. But if I do the same operation with the odd number, it always comes out to be 1. So that's how this thing is working. So yeah, since we encountered odd number of negative count, so what we're gonna do in our sum, we're gonna simply do this thing. We're gonna subtract it with twice the minimum value of the value. So you must be thinking, why twice? So let me just give you a simple example. Let's say I have this matrix, a simple one, minus 3, 2, 1 and 1. If I try to do an absolute sum of this, it comes out to be, if it is positive, this thing is positive 5 and then 7 now. As you can see, there is one negative number. So we know that after doing the operation, we're gonna pick this is the minimum value and put negative into it. So if I try to do a subtraction of this directly, it comes out to be 6. But if I look clearly, I can see that this is not the actual value. I mean, if I look and do sum up again, it comes out to be 5. Since these two neutralize each other, it becomes 0 and this 5. So what if I do twice of it? So if I do twice of it, 7 minus twice of negative 1. So if I try to do the same operation now, as you can observe that it comes out to be 5. So that is why we have taken 2 right at this place. So that's the main reason why I'm using 2. So if I try to submit it, hopefully it will work. I mean, I still don't know, but let's just see. Yeah, so it finally worked, and that's the trick behind it. Thank you.